Okay. Our topic for today is one of the most common chemical reactions of organic chemistry, which is substitution. Okay. Meaning you replace a certain element for a certain chemical reaction in organic chemistry. Okay? Substitution. Right? Example. So we have methane plus chlorine gas. Okay. Let's have first the chemical reactions according to the molecular formula. So we have all the our products here. So let's assume that we don't know yet our chemical products, but if you try to picture out that one, then you can have the specific products for this. Okay, in order for us to answer that or to have prediction of products, then we need to put this in a structural formula first. See, I will say methane. So C, single bond. Okay, this is methane or methane. Okay, A-N-E, methane or methane. Okay, so then you need to split this chlorine gas into chlorine, then chlorine like that. Okay, so it's gonna be like a reaction between the hydrogen and the chlorine. Okay, so you need to substitute the H positive here. Ta-da-da. Like that. Okay, so it will go up here. Ta-da. The chlorine will substitute the hydrogen here, and the hydrogen will come to chlorine. Right? It's gonna be a double displacement, but in terms of hydrogen alone. So our product will be H, single bond H, then H, then this one will go here to chlorine, then plus H will go here, hydrochloric acid. Okay, now what's this? What's the name for this? Remember, this is halogen. How can we name that? The rule says in Ayuba Chemistry International Union for Pure Applied Chemistry, you have to put that in the prior to the. This is methane. You will say chloromethane. Okay, this one. Now, get this chloromethane and band again with chlorine gas. It's just like making an elementary steps, and after that one we have our rate determining step, and after that we can have our final net chemical reaction. But in terms of organic compounds, at the point C, we will try to transfer here. Okay, H. Sorry guys, my whiteboard is very small, so I cannot intensify, right? Okay, chlorine. Chloromethane will be here now as your reaction. Again, plus C gas. The structural formula of chlorine gas is gonna chlorine, chlorine. 2 atoms. 2, 1, 2. So subscript 2. 2 times 1 is equal to 2. Right? Meaning chlorine plus chlorine. Okay, now, what will be our product here again? Okay, things like that. Chlorine will go to hydrogen here. Okay, so the first thing to do is go in the bottom rather than go up in the hydrogen up. Okay, first bottom. Okay, chlorine will go here in the edge. Okay, and the edge will go here also. Right? So it's gonna be, okay, H, C, H, Cl, then Cl, wait, then plus H plus Cl, HCl again. Okay, what do you call this one? This is dichloromethane. Okay, dichloromethane. Okay, then plus HCl. The same with this. And then again, we take out this one. Okay. And again, add ClCl. Things like that. You get the point? Until such time you can have the last step for that. I can't show you because there's no enough space, right? Okay. You get the point? Mm-hmm. So all we have to do now is, again, let's erase the space. It's not enough, right, to discuss in this way, and then it's very small. How can we do this? Okay. Okay, let's write at the top, say, dichloromethane. So let's forget for a while this one. We'll come back to that also later on. So I will make my writings so small so that I can save the space, right? So I have it. Oh my gosh! Dichloromethane, copy the structural formula. So H, carbon, H, chlorine, dichloromethane. So this is dichloromethane. So all you have to do is you have to be patient in dealing with organic chemistry, organic compound chemical reaction. So until such time you will reach the final destination. Okay, plus chlorine is equal to, meaning to say, substitution. Okay, actually we can say also that this is gonna be dehydrogenation because you take away the hydrogen, one atom of hydrogen from the reactant. So it would be like parallel to say dehydrogenation or substitution, right? Okay, so chlorine will go to the top of hydrogen to this place. Not the right hand because it's not allowed to go directly to the left, sorry, left. Okay, first at the top. Okay, bottom then the top. Okay, so here, and then H also will react to this. Okay, it's gonna be H. Okay, carbon, copy everything. Okay, then chlorine will be here. So chlorine plus HC. Oh my gosh. So what do you call this one? 1, 2, 3. Trichloromethane. Okay. Trichloromethane. What you will notice here is that you apply the prefix in naming. So see, chloro. We say chloro, that's actually mono, but you don't have to put mono. It's understood. That's why. And then di. Okay. Tri. Okay. Things like that. Make a point. Now to save space, let's just make this as a molecular formula or general formula. Okay, so I will convert this to C so that I can save the space. Sorry. Okay. Anyways, just listen. So CH4, chlorine gas, for the purpose of saving the space only. But anyhow, you understand equal this one. It's gonna be CH2. Oh, CH3. 1, 2, 3. So CH3Cl. Okay. Like that. Okay. CH3Cl. CH3Cl. So chloromethane. Since chloromethane is very clear, I have to erase the word chloromethane. Just put that in your mind that it's gonna be chloromethane. So we familiarize the naming of organic compounds. Not only the chemical reactions or how it is being structured or oriented, but also we can remember how to name. Okay, this one. Now get this trichloromethane, which is this one, as your reactant again. So HCCl, Cl, Cl plus chlorine, bond chlorine. So chlorine will go now to the left because there's no choice. There's no more hydrogen left. Only one left in the right. Okay. Then the hydrogen also will go back to the another chlorine atom. The other chlorine atom will be substituted like that, and going to hydrogen, and the other one also will go to the chloride. Okay. So these two chlorine, okay, the other chlorine will go there, in which there's hydrogen atom, but the other chlorine will stay and wait for the hydrogen to go there. You get the point? Okay, it's gonna be like Cl, C, Cl, Cl, Cl plus, okay, HCl. Okay, like that. Okay, now in this situation, how can you do this one? This is very unique because sometimes we will be able to be, we will be confused. Listen, actually, if you try to go with a systemic naming, it's gonna be tetrachloromethane. Okay, tetrachloromethane. That's why sometimes in examination, we are mixed up, or we cannot say directly that it's tetrachloromethane because in this form we don't see methane anymore. See, all are banded with chlorine. 1, 2, 3, 4, 4 chlorine banded with carbon. So how can you expect that that is a methane already? But the name of that is correct, tetrachloromethane or carbon tetrachloride, because most of our teachers taught us the carbon tetrachloride. Okay, CCl4. And this is more popular and famous than calling that as tetrachloromethane. But in the benefit of a doubt, to expand our knowledge, just remember this, because in the future examination, maybe it will come in also in the MCQ's examination, which is following as the same name of carbon tetrachloride. Right? A, trichloromethane, C, blah, 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 so on, so. And then you will be confused, oh my gosh. Don't tell me you will make a lot of structural formula like this. There's no more time to make orientation or structuring like this in the actual examination. That's why you need to remember. You get the point? So we need to have a lot of comprehensive memorization. Okay? So if you love to take, let's say, Bachelor of Science in Chemistry or things like that, or Master's in Chemistry, you need to have at least strong foundation in memorization. Okay? Because if you don't have that kind of memory, you will be lost somewhere along the way. Just like taking up medical science courses. Okay? You have at least a very strong foundation of comprehensive memorization. I'm not saying plain memorization. Comprehensive memorization. Understand it, analyze it, and then memorize. Okay. Things like that. Things like, okay, carbon tetrachloride plus HCl. Okay. Now, if you add these all reactions, okay, add this. This one is first elementary step 1. Okay, let's say there are 1. Go back here is 1. Okay. Ang chloromethane. The chloro, step 2. Okay. Trichloro, step 3. Carbon tetrachloride or tetrachloromethane, step 4. Like that. Add 1, 2, 3, and 4 so that we can come up with the final net chemical reactions. The same as what we did in our balancing of redox equation. The only difference here is we don't need to balance the charge, though we need to balance the atoms. Okay, but in this case, So it's obviously that when you, it's automatically balanced somewhere along the way. You don't have to worry. Okay, next let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why it happens like that? Because we don't introduce moles, atoms, and subscript in our structural formula. That's why we go directly, okay, to the structural formula of the reactants, and then also we come up directly with the formula of the products as well. Because once it has 3 formulas like that, then it will not be the same as, it will not be easy as like this. Okay, get the point? So this is introductory to understand, okay, the basic foundation, how to have a chemical reactions. Okay, things like that. So the same as math, the same as balance of, you know, the same quantities or the same compounds from the left and the right, then cancels that out. Here, try to have a visual inspection from 1 to 4. So start with 1 and 2. Okay, so makancel ang chloromethane. See? Cancel. Okay. Now, in the 3 and 4, makancel ko din mo ang trichloromethane. Like that. Cancel. Now, add all the remaining. Okay? Wala na ba makancel yung ara? Take a look. Okay? Huwag na pa ba makancel yung ara? If nothing, then proceed. You get the point? So what's left? Okay. Left here is CH4. Okay? Things like that. You get the point? HCl. 1, 2, 3, 4. We have 4 HCl here in the product. Okay. So in the product, what's left? Carbon tetrachloride or tetrachloromethane plus 4 HCl. Okay. CCl4. The same as C, single band C, single band C, single band C, single band C. The same like that. This is the products. How about in your reactants? Okay. Count. Okay. In your reactants. Okay. Ang dichloromethane, ma-cancel siya sa kilid. Yes, it will be cancelled also. The chloromethane, the same. Okay. Cancelled here. Okay. Now, chlorine gas, or chlorine band, chlorine, like that, it will not be cancelled because it's in the same position or in the same left portion or in the reactants portion. So all you have to do is to add them also. 1, 2, 3, 4. It's gonna be 4Cl2. Then what's left? CH4. So CH plus 4Cl2. So this is now our final chemical reaction, in which we answered already in our introductory part. I introduced you the reactants, and we don't know yet the product. And the products. The products are carbon tetrachloride plus 4 moles of HCl. Now, to ensure that it's been balanced, then again balance. Okay, hydrogen 4 balance. Chlorine 8, chlorine, okay, i-balance yung dinutanan. So 4 plus 4 balance, 8. Carbon, okay, 4 plus 1, 5. Carbon, okay, 4 plus 1, 5. Balanced. Okay. So, we erase this one. So this is only for better understanding that we can have really close to perfection analysis, and we can get directly what's the best products. But we can also go directly in our analysis like this. See? Based on my introduction, I said, okay, if you have a CH4 plus chlorine gas, you can automatically say carbon tetrachloride plus HCl, and you balance the chemical reaction. Okay? You will get the same like this. Why carbon tetrachloride? Actually, there's so many, right? Because you have chlorine and hydrogen. It's expected to have an HCl. Okay, things like that. Take note, there's another Cl that will form. Okay, so let's say HCl. This is taking away the first Cl of this LC gas. Right? Wait. So there's still another Cl here, and there's carbon here. Okay? CCl, supposedly, in your analysis. And there's 4 hydrogen. So it's easy to balance it because we have already etched another here. Now, CCl, it looks like unstable in nature. This one, CCl. This one. So, by analysis, if you have CCl, then you need to draw the structural formula. So, carbon, Cl. So, there's 4 valence electrons in the outermost shell. So, 1, 2, 3, 4. Now, if you don't put another chlorine, so it's unstable. You just follow this, right? So you need to put chlorine so that it will be balanced like this, like this, like this. So that's why put 4 here. So you can predict without using the structural formula knowledge, in which it will take a longer time. That's the purpose only for the understanding structural formula. Okay? And adding all the steps. But it's easy to analyze, right? This is the most difficult part in which the prediction of the products, because once you will have the products wrongly, then the entire, answer of your question like that in the examination, you will be wrong. Okay? Unless there is reactant and there is product, and it's easy to balance the chemical reaction. But what is expected and unexpected, they will give only the reactants in the examination or in the test. You will be the one to produce the products. Things like, there's a lot like that. Okay? Especially in the future examination. Okay? Now, this is not yet balanced. Right? So, balance the chemical reaction. Okay? Things like that. So, since, chlorine 2, 4, 5. Like that, no? Okay, so in this case, this is my weakness. I cannot balance directly through, what do you call this one? Trial and error method. See why? Because there are 2 chlorine here. See? Chlorine with 1 subscript and chlorine 4 subscript. Now, there's only 2 chlorine here. I cannot put 2, I cannot put 1, I cannot put 3, because if you put 3, 6 to 4 only. So it will not balance directly here. It's for me, it's not convenient. Still, I will use the algebraic expression of balancing the chemical equation. So, medyo na akong ganahan ang algebraic expression. Okay, chlorine. Okay. Let X of atoms of chlorine, okay, to equal the number of atoms of chlorine in the products, because obviously, this chlorine atoms here in the reactant is deficient in the number of atoms compared to the product. So, you will say, let X as the atoms of chlorine to equal the product. So, X times 2, 2X is equal to 4 times 1, 4, plus 1 times 1, 1. 2X is equals to 5, X is equals to 5 over 2. Then put the 5 over 2 beside the chlorine, like that. And then erase that and multiply to something, because you have the denominator. In math, again, if you have denominator, to cancel that out, multiply to a certain number so that it will become a numerical figure and an integer. Multiply by 2, cancels that 2, that's it will become 5. So, but you need to multiply all quantities. So, 2 times CH4 is equal to 2CH4. Okay, 5, because cancel the 2, 2. Okay, 5 moles of chlorine gas. This is 5 guys, huh? Okay, 2 moles of carbon tetrachloride plus 2 moles of HCl, like that. Now, balance, is it balanced or not? Okay, we'll say, carbon 2, okay, like that. Okay, carbon 2. Hydrogen 8, hydrogen 2, only 2. So, it's not balanced, the hydrogen. You get the point? 2 CL, 2 CCl4, okay, 5 Okay, Cl2 and 2. So it's not balanced. Our main target is to make equal here. Okay? If it makes equal, then it will be perfect. We're just proving through the other method. Because it will take a longer time by using that one structural orientation, structural formulation. Okay, now, you cannot balance the hydrogen because it's very difficult. So, again, we use algebraic expression. Okay, hydrogen in the right, or the 4 times 2A is equals to hydrogen in the left, 2 only. So, which is deficient? Of course, the hydrogen in the HCl. So, put X here. Let X as the unknown atoms of hydrogen in HCl to make it equal to the hydrogen in the methane. Okay, so 2 times X is equals to 2X. Therefore, X is equals to divided by 2, cancel, divided by 2. X is equals to 4. Then put 4 here. Diba? Like that. So, it's gonna be 8. Then, copy that. Okay. So, 2CH4 plus 5 chlorine gas is equals to 2CCl4. Right? Okay. Plus 8 HCl. Like that. Okay. 2CH4 plus 5Cl2 is equals to 2CCl4 plus 8 HCl. Right? Okay. Now, so balance again. So chlorine 10, chlorine 8. So 4 times 2, 8. Chlorine here is 16. So it's not balanced. So again, algebraic expression. Okay? Be patient, ha? Okay, mga palagingging. Be patient until such time you will get the correct answer. Like that. Okay. Now, for the chlorine. Okay. Balance the chlorine. So, 10 here. Chlorine, 4 times 2, 8. Chlorine, 1 times 8. So, 8. So, 16 versus 10. Deficient here. So, let X also beside 5 moles of chlorine gas. Okay. So, you will see again. 5x is equal to 16. Then x is equal to 16 over 5. Right? Okay, 16 over 5. So put the 16 over 5 here beside 5 moles. Okay, then multiply by 5 the whole thing. Cancel, it will become 10CH4. 16. Okay, 16 over 5. 5 cancel. Okay, 16Cl2. Okay, 16Cl2. But we don't need to multiply this by 5 because here only it can be cancelled already by itself the moles of Cl2. Okay? Get the point? Unless there's no 5 here, we need to multiply the whole thing by 5. But there's 5 here. So 16 over 5 times 5. Cancel the 5, 16, right? So 16 moles of Cl2. Okay, is equal to 2 moles of carbon tetrachloride. Okay, plus 8 moles of HCl. Now, we have now this one. Okay, is that the same with here? Now, take note. Divisible by 2, right? So it will become CH4. Okay, 16 divided by 2, 8 Cl2. 2 CCl4, 2 4HCl. Okay, 4HCl. So ang imong product correct. Okay. Ang imong CH4 correct. Okay. Now, ang imong HCl. Why HCl? There's a deficient of 4. Okay. Then balance again. Okay. 8CCl, 16. Right? Chlorine plus, chlorine gas, 16. Chlorine 4, it's only 8. So, change this with 4. Right? Because you are balancing. The rule of balancing. Then again, balance again. So 4 chlorine, 8 chlorine, 8 chlorine. Oh, okay. So 8 chlorine. So hydrogen 4, hydrogen. Okay, 4. Hydrogen 4. Okay. 8. Okay. Balance 4 hydrogen, 4 hydrogen. Okay. 8 chlorine, 8 chlorine. Chlorine plus chlorine 4. Okay. Carbon, carbon balance. So CH4 plus 4 Cl2 is equal to Cl4 plus 4 HCl. Things like that. Okay. You get the point? Right? So, muna siya ang atong answer. Okay. It doesn't mean also, guys, that when you use the algebraic expression, it's always automatically correct, but you still have to final balance it. Okay? Because you say confident, that's what. Okay? Because you say confident, that's what. I use the algebraic expression, I still have to said, right? The number of moles. That's why I put 4 because it will not balance 8. Right? Okay. So in this case, I mixed already the algebraic expression with the trial. But it's very difficult to have a trial and error method in this case because we use a lot of fraction. Okay? So that's why others use the structural formula instead of prediction like this, because they will also encounter also difficulty in balancing the chemical equation. But in here, you don't have to balance, you have to count only during elementary steps, right? 1, 2, 3, 4. What? How many less HCl? 4. So 1, 2, 3, 4. So 4 HCl. How many carbon tetrachloride? Only 1. So CCl4. How many CH4? Only 1. So CH4. So how many chlorine gas? 4. So 1, 2, 3, 4. But in here, you need to balance. That is another difficulty for all of us or common of us if you don't use the algebraic expression. Now, trial and error method. But the prediction is the first thing to analyze. If your prediction is wrong, then entirely you will be wrong. Okay? Things like that.